Okay, so we're going to start off with functions in 2.1, and it's just kind of a background on functions. So many of you already have an idea of what a function already is. I'm just going to give kind of a formal definition to it. A function is a relation between a set of inputs and outputs, where each input is related to exactly one output. So in this case below, we have our mapping. Sometimes it'll be referred to as a mapping. F of x takes something from the input and maps it to something from the output. And what makes it a function, what makes this relationship functional, is that every single input has exactly one output that it goes to. So there's no choice, okay? We will often refer to the inputs as the domain, and we will also often refer to as the outputs as the range. I've even seen it called codomain in higher levels of math, but I'll try to stick to range for this class. So sometimes we can look at something that we think is not a function. So in this case, f of x maps 1 to 4, 2 to 4, and 3 to 4. So even though all three of them go to the same number, each one of them map to exactly 1. It wasn't like if you took 1, it could be a 4 or it could have been a 7. It's always going to be 4. The 2 is always going to be 4. The 3 is always going to be 4. So they're still mapping to only one value. So this would be still a function. Now, it's not a one-to-one function, but that's something we'll get into in a different section. So let's say we have another mapping. Let's say we have 1, 2, 3. And over here we have 4, 5. So in this problem, let's say we have 1 goes to 4, and 1 goes to 5, and then 2 goes to 4, and 3 goes to 5. So this would not be a function because of this guy. 1 could either be a 4 or 1 could be a 5. Okay, so that's what makes it non-functional, is the fact that 1 could be two different things. It doesn't map to exactly one thing. So this would not be a function. And again, many of you already know this. This is something you've talked about with many of your math instructors before. F of x, this is the very common notation we use to write a function. Doesn't mean it has to be a function, but in general, that's how we talk about it. So whenever we're using f of x or h of x, normally we're referring to it as a function. And so are the following functions. So I have y equals x squared minus 2x, 5x plus 7y equals 10, and f of x equals 2 over x minus 3. So the main thing about a function, if you know something's a function, is that when you plug a number in, you only get one answer out, okay? So in this particular case, this problem is definitely a function because no matter what I plug in there, I'm only going to get one answer, okay? So in chapter 2.1, we can tell just by looking at it that if I do y of 7 or y of 2 or y of 8, I'm only going to get one answer. I'm not going to say, well, the answer is 7 or the answer could also be 10. That won't happen. So yes, this is a function. Now this one, hopefully you guys know that's a line, and you guys know that all lines except for the vertical line are functions. So yes, this is a function. And now this is a rational expression. This is something we'll talk about later in the class. But now think, is there a number that you could plug into here that would break it? Well, I could plug 3 in and this would become 2 over 0, which is undefined, okay? But is there a number that you plug it in that would give you 2 answers? So if I plug a 7 in, am I going to get 2 different answers? Or if I plug an 8 in, am I going to get 2 different answers? Or I may get ugly answers, but I'll always get the same. So this is also a function, okay? So something that would not be a function would be something like this. F of x, or let's say y equals, plus or minus the square root of 3x plus 1. This is not a function because you're going to be getting 2 different answers when you put in a 0, or when you plug in a 1.5, or you plug in a 2. You're going to get 2 different answers, so this is not a function. Okay, now in your mind, you might be thinking of very few things are ever not functions. Well, we have x squared plus y squared equals 9. This is actually a circle that we'll learn about much later in the class, but this is also not a function. And that's because if we try to solve for y squared and then solve for y, we would get plus or minus. So we would get multiple answers, and it would turn into a very similar problem to that. So these are things that are not functions. And again, most of the stuff that you've learned in your life are functions. In mathematics in general, we love functions because they're so predictable. We know what we're getting out of them. okay? So far, you guys kind of know a lot of functions already. Now you can look at coordinates. You could look at the set of coordinates 2, 3. Oops. You could look at 4, 1. So these are just points on a graph. These aren't connected. These are just points themselves. We're not actually going to like connect them. So this is just a set of 4 points. And you would say, is this a function? Well, the only way it would not be a function is if one of the x coordinates had 2 different y coordinates. Well, look right here. This has an x coordinate of 2. This has an x coordinate of 2. So they both have x coordinates of 2, but they go to 2 different answers. So because of these 2 guys right here, not a function. Okay, so you can look at just coordinates and tell if something's a function or not, because if there's ever 2 x's that go to different y's, that's a problem. That means that it's not a function. Now, what if you have a bunch of x's go to the same y? Well, that's fine. That's still a function. It's when it's more than one x going to different y's. Oh, I'm sorry, more than this, how do I say this? The same x going to different y's is when you kind of got to be careful with points like that. Okay, and you can also use it with like they do things like with birthdays and things like that. Now, one thing that I want you guys to take from this section is how to evaluate a function. So if I say f of x is equal to negative 3x squared plus 2x, and then I ask you to evaluate it at f of 3, then I want you to evaluate it at f of x plus f of 3. And then I want you to do f of x plus 3, okay? So let's pause the video and you guys see if you remember how to evaluate this. More than likely you guys know how to do this, but just give it a shot real quick and then unpause the video when you're done. Okay, so hopefully all you did is you said negative 3 times 3 squared plus 2 times 3. So this would be what? Negative 27 plus 6. So this would be what? Negative 21. Okay, no big deal. Let's see here. Next one is f of x plus f of 3. So we know that f of x is worth negative 3x squared plus 2x plus f of 3. But we just found out that f of 3 was negative 21. So this is plus negative 21. So this will become negative 3x squared plus 2x minus 21. And that would be our answer for that. No big deal. Now, f of x plus 3 is different than this. They are not the same thing. And I'll show you. So f of x plus f of 3 is not the same as f of x plus f of 3. So you can't distribute the function like this. And I'll show you why not. So f of x plus 3 means that you literally take x plus 3 and you plug it in here for x and here for x. Okay. So I'm going to say that f of x plus 3 is equal to negative 3 times x plus 3 squared plus 2 times x, but instead of x, we're going to use. So once again, x told me to. Whatever they said, that's how the notation works. It says f of x plus 3. So whatever you're plugging in for times x squared plus 6x plus 9. I just distributed real quick, plus 6. Now let's clean this up. 3x squared minus 16x minus 21. Answer does not match this answer. Distribute the f. You cannot do this. This does not work. You cannot do it. Okay. So we just kind of verified that they're not. That's not how. Can't do that. You have to do f of x plus 3. You have to plug the x plus 3 in, and that is different than saying f. Okay. So let's move on. Okay. Let's do what I want to share. want to talk to you guys about the difference quotient. So the difference and we'll talk more in depth about what it is. The difference quotient of a function f at a given at f of x plus h minus f of x all over h. Okay. So this is a simplified version of the difference quotient because technically there's actually cancel, cannot equal 0. Okay. So what the homework is going to ask you to do, and again, this is just kind of practice manipulating your algebra. We're not going to do much with it until we get into Calc 1, but we'll talk a little bit of this later on as well. But in pre-calculus, we manipulate our algebra. So what I do, ask you to find the motion. I have part A, let's do f of x equals negative 2x plus 1. And for part B, I'll do a little bit harder one. Let's do f of x equals 2x squared minus 5x plus minus 1. Okay. So what we're going to do now is we're going to then do f of x plus h. That means we literally have to plug x plus h in for x. So this is going to become in red. So this is going to become negative 2 times x plus h plus 1. This, all of this, is just f of x plus h, right? And we have to minus f of x, but f of x is actually negative 2x plus 1 divided by h. Will become negative 2x minus 2 1 plus h. And with the difference quotient in there will always be canceling. So from 0, the 1s will cancel. Left with negative 2h over h, which is 2. So this would be our simplified version of the difference quotient, okay? Let's see here. Let's try this one over here. So pause, you just plug in the difference quotient or plug the explanation. So we use this formula right here, and we're going to plug in explanation, subtract off the original function x. So I'll give you a try, and then we'll go back over it together. Okay, so now we're going to have 2 times x plus h quantity minus 5 times x plus h minus 1. So all that is just subtract off of x, which is x squared minus 5 minus 1, all divided by, so let's see what this cleans up to, 2 times x squared plus 2xh plus h squared minus 5x minus 5h, oops, minus 1 minus 2x squared plus 5x plus 1. It's just a lot of writing, but it's actually not hard math. It's just a lot of writing out stuff. It looks a little overwhelming, but it's really not bad. So this is 2x squared plus 4xh plus 2h squared minus 5x minus 5h. And remember, a lot of this is going to cancel. And if it doesn't, you probably messed up. I'm just going to be honest with you. That's kind of the way the difference quotient goes. So let's see what cancels. This 2x squared and this x squared. This 5x and this 5x. This negative 1 and this plus 1. So I think that's it. So let's write what we have left. 4xh plus 2h squared minus 5h all over h. I'm going to factor out the h. And that's going to leave me with 4x plus 2h minus 5 all over h. H's can now cancel. And then we are left with a simplified version of this answer, which would be 4x plus 2h minus 5. Now, what we'll learn in Calc 1, those of you that pass this pre-Calc 1, that means that h is 0, which of this function is 4x minus 5. So this is kind of why we're learning the difference calculus as well, to be look at hard. So to do this type of. So last thing for this video, finding the domain of a function. Okay, so finding the domain. Basically, the domain, a good way to get domain to plug in the problem. So you try to think of all the things that are in there, and sometimes it gets over. So a better way sometimes is to think of what you're not allowed to plug into the problem. So that can help you. So let's say that I have g of x equals x squared minus 9. Is there anything that would have like division by 0 or complex numbers or imaginary numbers? Can I plug in x and I'll always get an answer? So pick any number in your head and plug it in. The answer is yes. So the domain for this problem is actually negative infinity to positive infinity. This is interval notation. This is the notation I'll use. If you guys have trouble with this, feel free to ask me about this at a meeting. The next class meeting we have, interval notation can be something you talk to me about, and I can go over it with you. But in general, the parentheses mean get really close, but never actually touch. And that's literally the definition of infinity. You can get as close as you want to infinity. Also, I want you guys to understand is what is as long as infinity or positive, getting answers, negative infinity, positive infinity. So all reals. Another way you know is all reals or all numbers. Okay. So of x equals the square root of 3 minus 2x. And domain, remember, you're trying to think, what am I allowed to plug in here? What you do is you take the inside portion, you take 3 minus 2x, and you set it greater than or equal to 0, because you want whatever 3 minus 2x is to always be 0 or bigger. So by setting it greater than or equal to 0, that's the only thing you're going to work with. So then we're going to, let's see, minus 3, minus 3. So then we have negative 2x is greater than negative 3. Then we're going to divide by negative 2. And then hopefully you guys remember that whenever you divide or multiply across an inequality, whenever you divide or multiply across an inequality, so we get this, you switch the direction. So this right here, because I divided by a negative 2, the direction of my inequality goes from greater than to less than. So then when I want to write this, I just draw my little number line just to kind of see it. And I say, well, here's 3 over 2, and it says to shade this direction. So you use a bracket. You use a bracket when you have, if you just less than or greater than, you use parentheses. So I'm going to use a bracket right here, okay? So then my interval is actually from negative infinity. You always start with the smaller number on the left. So think of all the numbers over here. These are all really small negatives, right? So negative infinity, and I'm going to stop at 3/2. And that would be my answer. That would be the solution to, that would be the domain. Okay. Now let's try one more. So now let's say that I have g of x equals, let's say, x plus 4 over x squared minus 2x Okay, so in order to domains have to break. Well, a fraction has a problem when the denominator is 0. So I'm going to factor this, and this is going to be x or over x minus 3, 1. Okay, that means that I have to worry about when x equals 3 and equals 1. So x equals 3 and x cannot make, because if I plug -1 into here, 0. Thing divided by 0, which we're not allowed to do. These I cannot use. So you can do it away. This is interval notation. So you would say that x is -1 here, and here's 3 here. Would be from -infinity to -1. So I did this section. Then you -1 to 3. Started again from 3. All 3 of those sets of numbers work. So I want to join them together. And that's what the union does. The union allows us to join those together. So we're not allowed to use -1 and we're not allowed to use 3. And remember, parentheses mean get really close to -1 and get really close to 3, but never touch them, which is what we want, because if we did actually make it, we would be dividing by 0. Okay, there's a nicer way to write it. So this is set builder, right? So this is, I'm sorry, this is interval notation. Okay, so this is interval notation, but there's another way called, let me do it in blue, called set builder or set notation. And what that does is it says the squiggly line for set notation. So this is set notation, x such that x cannot equal -1, comma, x cannot equal 3, close the set. So this is also a totally acceptable way. If the problem asks for set builder notation, you just tell them what x cannot be. So again, I want to get this line means x such that x cannot x can be anything else other than these in the real number plane. Okay, so that's the, for the most part, that. Between 2.2 and just to keep this video short, I'll cover some more stuff from 2.1 in 2.2 as well. But that's going to do it for this video, guys. Hopefully this helps you get started on some of the homework.